If you just look down at the shoes you're wearing or, the phone you're probably holding right now, you're looking at something that has traveled thousands and thousands of miles. It's a real physical piece of this huge, basically hidden network that connects the entire planet.
And that network, that's what we call the global supply chain. It's so much more than just a bunch of roads or ships. It's this highly choreographed dance of materials and factories and trucks and boats that makes sure whatever you want to buy gets to you.
Exactly. And today, we're going to dive into that system. We want to map out three main things. First, how this whole thing even started from these ancient, slow-moving caravans. Then, how it works today with all its amazing technology. And finally, what happens when this really complex web, snaps.
Let's start by rewinding a lot. We're talking thousands of years because global trade itself, that's not a new idea at all. People have always wanted to get things that they just couldn't find or make where they lived.
We're talking about the very first beginnings of a global economy, right? And it was all built on routes like the famous Silk Road, which, it wasn't just one single road, was it?
No, not at all. It was this whole network of paths that carried incredibly valuable goods. Things like silk, spices, precious stones, all the way from Asia across continents into Europe.
And the main thing defining that era was just the sheer physical challenge of it all. Merchants were relying completely on animals, camels, horses to haul these heavy loads.
Right, across incredibly dangerous deserts, over high mountains. The logistics were, well, they were brutal. Think about the time it took. A journey that we do in a few days now could take months, maybe even a full year back then.
And the risk was just constant. Bad weather, bandits, political problems. So because it was so slow and so risky, it really only made sense to move things that were worth a ton of money.
Exactly. If a little bag of spices could pay for a lifetime of work, it was worth the trip. You weren't going to move something cheap like basic wood or grain. It just wasn't worth the effort.
And that's the key, isn't it? Only moving luxury stuff. It proved the demand was there, but the technology to make everyday global trade possible, it just didn't exist yet.
But that was all about to change. Dramatically.
This is where the story completely shifts. If the Silk Road was the slow, difficult start, the real game changer was the steam engine. This was back in the 18th century during the Industrial Revolution.
The steam engine introduced speed and, just as important, reliability in a way the world had never, ever seen before. Steamships didn't need wind. They could travel faster, on a schedule, and connect continents much more reliably than old sailing ships.
And at the same time, you have railways just exploding across continents. Trains could suddenly haul these massive loads of raw materials, coal, iron, steel, so much faster than any wagon ever could.
And this new speed was absolutely vital because factories were popping up everywhere, mastering mass production. To keep those factories running, they desperately needed these huge, constant, and fast supplies of raw materials from, well, everywhere.
Speed wasn't a luxury anymore. It became essential for business. But to manage all this, they needed to communicate instantly.
And they got it, the telegraph. All of a sudden, you could send a message across an ocean in minutes. You could coordinate everything, ships, train schedules, factory orders, on a global scale. A manager in London could tell a supplier in India what they needed that day.
So businesses started looking all over the world for the cheapest and fastest way to get materials, which meant regular people, not just the rich, could start buying things made thousands of miles away.
But even with fast ships and trains, there was still one major bottleneck, a huge one. And that was how to actually move the cargo itself efficiently.
Right. Even after all that, moving stuff was this massive manual headache. Until we get to what is probably the most boring, but also maybe the most important, invention of the mid-20th century.
The standardized metal shipping container. It's hard to even imagine what it was like before this. Ports were just chaos. Workers had to physically lift and carry every single barrel, every crate, every box onto and off of ships by hand.
It sounds incredibly inefficient. Different size boxes for everything, nothing stacked neatly, you'd waste so much space.
Totally. The solution was standardization. The brilliant idea wasn't just making a strong box, it was making every box the exact same size. That simple change meant you could stack them perfectly and incredibly high on these huge, specially built ships.
And that standardization created a totally seamless connection between all the different ways of moving things.
Absolutely. Because they're all standard, a giant crane can lift one off a ship, place it right onto a truck chassis or onto a train car, and you never have to unpack the contents. It's called intermodal transport.
So a product, Let's say 1,000 laptops can go from a factory in Vietnam to a store in Ohio and stay inside that same locked metal box for the entire trip.
And that right there dropped the cost of shipping things across the ocean by something like 90%. It was a revolution. It's what really allowed companies to make things anywhere in the world because moving them became so cheap and predictable.
Without that simple box, the shoes and electronics you own would probably be 10 times more expensive. Which brings us right to how this whole global machine works today. It's not just moving boxes anymore, it's managing an incredibly complex flow.
A modern supply chain is a true network. It connects hundreds of different companies across dozens of countries just to make one single product. Let's use a real-world example, like a smartphone, and just trace its journey.
Okay, so step one has to be raw materials. That means pulling stuff like oil for the plastic, rare earth minerals for the screen, and copper for the wiring out of the ground in different places all over the world.
Step 2. Those materials travel to specialized factories, maybe in Taiwan or South Korea, and they're turned into really complex parts like microchips or camera modules.
Then step 3, all those tiny complex parts get packed into those standardized containers we talked about and travel across the ocean to a different country, maybe a huge assembly plant in China or Vietnam where the phone is actually put together.
And finally, step 4. The finished phones are shipped out globally by plane for the really urgent stock, or by ship to big warehouses, and then by truck to the store where you buy it.
And the main goal of this whole complicated dance is pretty simple. Companies are always looking for the best mix of materials, specialized workers, and low costs, wherever they can find them on the planet.
And if you think of that whole chain as a living thing, then technology is definitely the brain that keeps it all running.
Oh, for sure. Technology does the impossible every single day here. One of the biggest things is prediction. Computers use special software to predict future demand. They're trying to figure out how many phones people will want to buy 6 months, even a year from now.
And they have to predict that far out, because if they get it right, they can order all the parts in time. It reduces waste and makes sure the shelves are always stocked. It's about seeing the future to manage the present.
And then there's just the physical movement.
Yeah.
We rely so heavily on GPS and satellites. They guide the ships and trucks to find the absolute fastest routes, which saves a massive amount of time and fuel.
You also see incredible automation, especially in those giant warehouses. You have robots picking up and moving heavy boxes way faster than any human could, getting things ready for that final delivery.
And finally, communication. It's all digital. Tracking systems mean every container, every pallet has a kind of digital fingerprint. So if a factory is running low on a certain screw, the computer can automatically send an order to the supplier. No humans involved.
That whole tech infrastructure just cuts down on mistakes and makes sure things arrive exactly when they're needed. Without it, modern global shopping would just, well, it would collapse.
So if you connect that technology to where things are actually made, you get to this idea of a global division of labor. Companies don't just pick countries at random. They choose them based on specific skills and costs.
That's the why behind it all. For example, a country like Taiwan has a highly trained workforce, and they've invested for decades in making complex computer chips, so they've become the world leaders in that one specific thing.
Whereas other countries, maybe Vietnam or Bangladesh, they might specialize in assembling things like sewing clothes or putting together electronics, often at a lower labor cost.
Which means your smartphone is a truly international product. It could have software designed in California, chips from Taiwan, a plastic case made from oil drilled in Saudi Arabia, and be assembled in Vietnam. One phone, 10 different nations.
And that trade creates a massive number of jobs. It drives economic growth in developing countries. And this is the key for you, it keeps the prices of things we buy remarkably low.
But it also creates this really tightly linked global economy. Countries become dependent on each other for materials, for manufacturing, and for markets to sell to.
But this long, complex, superdependent system has a huge weakness. It's built for speed and efficiency, but that makes it incredibly fragile.
And that fragility really comes down to a strategy called just-in-time delivery, or JIT. This is the peak of efficiency. It means a factory gets the parts it needs exactly when it's ready to use them. Not an hour before, not an hour after.
That sounds impressive, but also really risky. Why would a company do that? What's the benefit of that perfect timing?
Money. It saves them a massive amount. They don't have to keep huge piles of extra parts, which we call inventory, sitting around in expensive warehouses. If your cash isn't tied up in inventory, you can use it for other things.
So the benefit is huge cost savings, but the risk has to be just as big.
The risk is a single point of failure. If there's any delay, a ship is a few days late, a truck breaks down, the factory might have to stop immediately because they have zero backup parts. JIT requires perfect day-to-day planning.
Which is why people always describe the supply chain as a long row of dominoes. One little problem can knock the whole thing down. And we've seen so many of these disruptions recently.
Exactly. A shortage of truck drivers in one country means food can't get from the farm to the store. Or a big storm hits a key port and suddenly ships can't dock, trapping millions of dollars of goods just sitting out on the water.
And sometimes it's just one thing in the wrong place. Remember when that single giant container ship got stuck sideways in the Suez Canal?
Oh, absolutely. The Suez Canal is one of the most critical shortcuts in global trade. When that one ship got stuck, it blocked over 400 other ships. The entire flow of trade between Asia and Europe just froze. That's the JIT risk playing out on a global scale.
And it can be even smaller things. A fire in one factory that makes, say, 70% of the world's microchips, and suddenly car companies and phone makers everywhere have to slow down or even stop production.
So to manage this, smart businesses are now moving a little bit away from pure JIT. They're creating what's called safety stock. They keep these small, strategic piles of extra supplies in warehouses just in case one of those dominoes falls.
And beyond those logistical problems, there's the environmental cost. Moving goods thousands of miles burns a colossal amount of fuel and creates a lot of emissions. Plus, all the packaging creates tons of plastic and cardboard waste.
It's a huge challenge, but companies are working on it. One strategy is slow steaming, where ships just sail a little bit slower. It saves a surprising amount of fuel.
We're also seeing a push for electric trucks for that last part of the delivery. And it's important to remember, shipping by sea is still way more fuel efficient than flying things in a cargo plane.
Another huge, unpredictable risk is natural disasters. An earthquake or a major flood can just shut down an entire manufacturing region overnight.
And if that region happens to be where most of a certain car part is made, for example, then car factories all over the world have to stop. The problem isn't just in the disaster zone, it's everywhere.
So the big question for companies now is, how do you protect yourself from an act of nature?
And the answer seems to be flexibility, spreading out the risk. Companies are actively trying not to rely on just one supplier in one place. They're finding backups in different parts of the world.
Right. It makes the chain a little less efficient, maybe a bit more expensive day to day, but it also makes the whole system more resilient, less likely to fail completely.
Looking ahead, the way we move things is going to keep changing. Self-driving trucks, for example, are already being tested and will probably become common.
We're also seeing major tests with drones for quick delivery of small packages, which could, bypass traffic jams completely for that final step.
But the really disruptive one could be 3D printing. If it becomes easy and cheap enough, people could make certain things, custom parts, tools right in their own homes.
If that happens, it would radically shorten the supply chain. You wouldn't need to ship a finished product overseas at all. You just need to ship the raw materials for the printer or maybe just the digital file.
The future goal is always the same, though. Use smarter computers, cleaner energy, and more flexible suppliers to make global trade faster, safer, and better for the planet.
In the end, our daily lives completely depend on this invisible system. Global trade lets us enjoy products from all over the world and helps economies everywhere grow. It really just shows how deeply connected we all are through the things we make and buy.
What's fascinating to think about is this. If the simple shipping container lowered shipping costs by 90%, what's the one innovation out there that could eliminate the need for shipping altogether? Good luck with your studies.